In this video, we're going to look at more examples about redox reactions, but we're going to focus mainly on the decomposition of equations, not the formation, just to help us in understanding electrolysis. So here we have example. This lead to oxide will break down to give us lead plus oxygen. Now the first step, we're going to balance the equation. This is not balanced because here we have one oxygen, here two. And why two? Again, the question which I will keep asking myself until the end of my life. Why O2? Because O2 is a diatomic atom. I'll write them here: O2, H2, Cl2, F2, I2, Br2. So these are diatomic atoms, always exist in two. If you have an equation, you have one of these, when they break down, they will give you this atom with two molecule, two in its molecule. So lead 2 oxide will break down to give you lead plus oxygen. So here the oxidation number of lead is 2 positive and oxygen is 2 negative. So they will be 0 and here 0. Now we will balance the equation. Here we'll have 2 lead oxide and here we have 2, so 2 all now balance. We look at the equations here. So 2 Pb, 2 positive. Now to lose the positive charge, they will gain plus how many electrons? Every atom will gain 2 and we have 2 atoms, so 4 electrons will give us 2 Pb without a charge. This is reduction because it gained. So this reaction happens at the cathode or anode. At the cathode, because the cathode is negative and this is positive, it will go to the cathode. Now let's look at oxygen. 2 oxygen to negative. This oxygen will lose electrons, so I will write arrow. Then we have O2 plus 4 electrons. This lost, so it is oxidation. It happens at what? At the anode. At the anode. In the exam or something, you'll have a question about you have equation or without equation, then it will say the question, write the reaction which happens at the cathode. So you write this equation, or write the reaction which happens at the anode. This is the reaction that happens at the anode, and this is how to write it. Let's have another example here. We have copper fluoride will break down to give you copper plus fluorine. Okay, this also diatomic atom, but the equation here is balanced. We have two electrons of copper. They will just go to 2 atoms of fluorine. This is 1 atom and this is 1 atom. Now when they break, this will give it back its electron and this will give it back its electron. It will gain 2, so this is 2 positive and this is negative. It will be 0 and 0. So copper, let's write the equation. Copper, it will gain electrons, plus 2 electrons will give you copper. This is 2 positive copper ion, plus 2 electrons gives you copper. It gained electrons, so this is reduction. This reaction happens at what? At the cathode. At the cathode. Because the cathode is negative, this positive will be pulled, will be attracted to the cathode. Now let's look at fluorine. Here we have F2. It will lose 2 electrons, so we write arrow. Then it will be F. This is negative. It will be F without a charge, F2 plus 2 electrons. This lost electrons, so it is oxidation. Oxidation. So this reaction of fluorine happens at the cathode or at the anode? At the anode. Why at the anode? Because the anode is positive and this is negative. It will be pulled to the anode. I will remind you again, always the metal, the first one, will go to the cathode, the second will go to the anode. So let's have another example here. We have aluminum iodide here, will break down to give us aluminum plus iodine. This equation is not balanced. Why I2? It was I3, it became I2 because again iodine is a diatomic atom. When it breaks down, it will give you I2, no matter how much. I2, I1, I3, I1000, it will go. When it breaks alone by itself, it will be this 2. Now, what is the oxidation number of aluminum? It is 3. How I know? Because look here, IL, I3. So we use the cross method. This will go the oxidation of this, and this is the oxidation of this. So aluminum is 1, doesn't have any number. It means fluorine is -1. This aluminum here, iodine, is 3. It means this is the oxidation number of aluminum is 3 positive. So this is how we know the oxidation numbers. Here 3 positive and this is negative. It will be 0 and 0, but first we will balance the equation. Here we have aluminum 2 and here we have aluminum 3. So if I write 2 here, 2 times 3, 6. So here I will write 3. And 2 times 3, 6. So the iodine is balanced. We still have the oxygen. We'll put just 2 here. Now everything is balanced. Now let's do the redox equation. Aluminum first. We have 2El. It is 3 positive. Now aluminum positive, to lose this charge is going to gain electrons. How many electrons is going to gain? We have 2 atoms. Every atom will gain 3, so it will gain 6 electrons, because 2 times 3 is 6 electrons, gives you 2 aluminum. This is reduction, and this reaction happens at the cathode. Because it is negative, it will go there. Now let's look at iodine here. Iodine, we have 2 I3. Now this iodine is going to lose. How many is going to lose? Or say it will give us 3. This is negative. It will give us 3 I2. Now it will lose how many electrons? This will lose 1. Every atom will lose 1. We have 3 times 2, 6. So overall it will lose 6 electrons. Now this is oxidation. Oxidation. It happens at the anode. And the anode, because it's positive, will attract the negative. And let's look at another example here. We'll say aluminum oxide. Aluminum oxide will give us aluminum plus oxygen. Now to balance this equation, we're going to write here 2 and 3 and 4, because 2 times 2, 4. So now this is the oxidation number of it is 3. How do I know? From the oxygen, O3 means this is 3 positive, and this is 2 means 2 negative, the oxygen. There will be 0 charge and 0 charge. Any atom by itself, it is the charge of it is 0, but if it is combined with anything, the oxidation number is different. Now aluminum will have 2 Al2 as it is in the equation. This aluminum 3 positive will gain, every atom will gain how many electrons? Will gain 3. So 2 times 2, 4 times 3 is going to be 12. So this will gain 12 electrons to give us 4El. Now this is reduction. Where is going to happen? At the cathode. Because the cathode negative will attract the positive. Now this is aluminum. Let's look at oxygen. Oxygen 2 oxygen O3 will give this will lose electrons, so we write arrow, then we write 3 O2. The charge of this is 2 negative, then it's going to lose how many electrons is going to lose? We have 3 times 2, then times 2. 3 times 2 times 2 is going to be 12 electrons. This is now oxidation. It happens at the anode. Because it's positive will attract the negative. And I hope that helped. That was helpful for you for understanding electrolysis and how to write the reactions at the cathode and at the anode, and how to determine the number of electrons gained or lost, and how to write the redox equations. And that is until the next video. Ciao.